Okay, so looking at these examples, we now have all the different pieces of the vertex form included. We have both A and B and H and K. And it's really important to understand at this point that this is done in the order of operations. So the first thing is, looking at Gelmdas, the first thing we have is the grouping symbol, which in this case is the parent function. Then we have a multiplier divider because, looking at Gelmdas, by the way, the E in Gelmdas and the L are parent functions. So parentheses, exponent, or logarithm would produce a parent function. So then the next step would be multiply or divide, and the third step is the vertex, which is an addition or subtraction of input or output value, so it will come third. So let's take a look at how this would work. The first thing we have here is we have the absolute value. So I'm going to start by graphing the absolute values parent function points, which would be 0, 0, negative 1, 1, 1, 1, negative 2, 2, 2, 2. So that's step 1. Step 2 is to apply the multiplier or divider. Now in these first couple examples, I only have one or the other, but you could have both, and that's really important. So in this case, we have a negative, and that is going to multiply all of the output values by a negative sign. So what that looks like in this case, since I'm multiplying by a negative, is this vertex point, it is not going to move. Okay, it's going to stay right there because 0 times negative is still 0. But this 1 will now be negative 1 in the output direction. So negative 1 was 1, now it's negative 1, negative 1. This will also be negative. This 2, that is at positive 2, will now be negative 2, and this 2 over here that's at positive 2 will be negative 2. So you can clearly see that the parent function was reflected over the x-axis. And then from there, then we will move it to its vertex, and we can see here that there is no h, so the vertex is 0 for h, and the k is 2, so we'll put a 2 there, and that's our last step. So we're going to go to the point 0, 2, and we're going to graph the graph going downward, like this, as opposed to going upward. Now some students will need to erase to be able to see that. I like for students to see in the notes all the different steps. But that's basically the whole entire process is only 3 steps if you follow this 3-step process that I'm showing you. All right, let's take a look at the next one. We have the square root. So the square root graph has a parent function of 0, 0, 1, 1. Don't know the square root of 2, don't know the square root of 3, square root of 4 is 2. If I had a big enough graph, the next one would be 9, 3. There are no negatives. So then I look at where the multiplier is. Oh, I've got to be careful. When I have a divider, I actually need to rewrite the problem because it must be factored out. And this is something that is super important because it's actually going to change the value of h. If I take this negative out and put it in a parentheses, it's actually going to make this 2 a negative 2 as well. Now, why does that happen? We're factoring out a GCF of negative 1. So when I divide x by negative 1, it becomes positive x. But when I divide by 2 by negative 1, it becomes a negative because you take a negative away from a positive and it becomes a negative. So that's going to switch. It looks like the graph has a value of h that's negative 2, but it's actually a positive 2. You've got to be very careful there. Okay? It does have a k value of 0. So let's go in order. So the next thing I'm going to do is I'm going to graph the divider of input values. Meaning I'm going to divide all my inputs by negative 1. So the height is not going to change, okay? But the input values will change. Meaning this is still, the nice thing about this vertex in the parent function, it never changes. It's always 0, 0. But instead of being forward 1, 1, it's now going to be backwards 1, 1. And instead of being forward 4, 2, it's now going to be backwards 4, 2. And so that is the reflection over the y-axis. Remember, the reflection occurs over, right? So if I'm changing the input values, that means I'm changing the x values. And so reflections occur over what stays the same. So the y stayed the same, reflects over the y-axis. All right, so then the last thing to do is to move that vertex. So my vertex is going to be moved to 2, 0. So 2, 0 is here. I'm then going to do the same thing I did in these green dots. So 1, 1, and then 4, 1, 2, 3, 4, 2. And so that would be my final graph. Oops. Okay, so let's take a look at the next one. So the next one we're going to do, oh, by the way, at this point, it's important to talk about what actually happened. So was there a translation? Yes, the original parent function was translated up to. Was there a reflection? Yes, it was reflected through the x-axis. Some people say over, and I use these interchangeable, but I think it's, you can see it happening through the x-axis, so that's also a word you can use. In this one, we said it translated right to, which it did. It moved to the right to on the x-axis, and it reflected through the y-axis. All right, let's take a look at the greatest integer function again. So for the greatest integer function, the parent function is simply to graph what appears to look like a line, right? So we have 0, 0, 1, 1. Again, all parent functions share those 2 points, which is a nice place to start if you kind of get stuck. Okay, negative 1, 1, and negative 2, 2. I'm then going to look for a multiplier or a divider. And so the multiplier is in the front, and that's going to change all of my output values. So again, if you ever get stuck, remember that the vertex is always going to be right here, but the output values are now becoming negative. And the ones that are negative, because you're multiplying by a negative, 2 negatives will now make a positive. Okay, so that reflection basically took this dot and brought it down here. And if I was thinking about barbells, this barbell will now be drawn down here, just reflected over the x-axis. Okay, so let's talk about what happens if I now look at my vertex. So my vertex, I have no h, so no movement right and left. That'll be 0. My k moved it up 1. So my actual vertex for this graph will be located at 0, 1. And I'm now going to draw, basically mimic that red graph with my blue graph. Okay, so now I'm going to draw my barbells going out from here. Okay, so that's what the graph will actually look like. Now, one thing we have to be careful about, again, if you need to erase because that bothers you, you may, is we need to make sure that we take this parent function and we get in the habit, again, it looks like I've limited the domain and range, but this graph does not have a limited domain and range. So we will need to get in the habit of filling the graph up with different graphs. Finishing the graph up with consistent graphs. I meant to say that. Just be careful that you don't leave that on a quiz or a test, leaving it without the completed graph. And if you don't like that dangling one, you can go ahead and do that. No one's going to be upset with you for drawing off the graph. All right, so now we're going to look at number 4. And what I want to train you to see is, man, if I have a divider, I just really need to start from the very beginning and rewrite that by taking that divider out. And if I take a divider out, I have to put another set of parentheses in, and that's going to change that value as well. Remember, negative means opposite, if you want to just simplify it that way. So if I have a negative that I took out from the x and made it the opposite of that, which is positive x, this will now change to a 2 as well. It's super important to understand that, and it just needs to be something, it's something that lasts throughout all of Algebra 2 and upper level math. It is technically factoring. As everybody knows, factoring is a critical thing in upper level math classes. But it starts right here with graphing. And just remember that negative means opposite. All right, so let's graph the parent function for the cube. And the parent function for the cube is 0, 0, 1, 1. Don't forget to make your axis go by 2's. Then you have 2, 8, right? And then you have negative 1, negative 1, negative 2, negative 8. Okay, and then from there we're going to apply the divider. Remember, that's going to divide the input values. So again, luckily the vertex stays right here at 0, 0. But this one that's at positive 1 on the x-axis will be at negative 1 on the x-axis. This one at negative will be at positive. The height stay the same, but the movement right and left, instead of being positive, becomes negative. So this one will now be, instead of being at 2, it'll be at negative 2. Height is the same. Here at 2, a negative 2, it'll be a positive 2. And then I'm going to graph the graph using, remember, don't look at this one. One effective thing to do is when you factor out a GCF, just scratch out the original problem. We now need to look here. So if that's 2, h was negative 2. It's always opposite, and that 1 will stay the same. So now I'm going to graph the vertex at negative 2, 1, and then I'm going to mimic this green graph. So I'm going to go this way and then up 1, didn't quite get it, and I'm going to go this way 2 and then up 8, so right there. And then here I'm going to go, looking at the green graph, I went back and down, and then here I went 2 and then down 8. So again, one thing that some students like having all the dots. I will tell you that in order to do this so your teacher can actually grade it, you're going to want to only draw the actual answer with lines and arrows. That way they know what to grade. If you draw all of these with lines and arrows, it's impossible to grade. Or just erase whichever you want to do. So when I look at this one, it had a translation of up 1. You can see it very clearly. So you'd say translated up 1. The reflection in this case was over the x-axis. Remember, we started with this black one and it reflected to the red one. The translation here was right 2 and then up 1. Actually was left. Let me fix that. And then the graph was also reflected through or over the y-axis. Now the most tricky thing here is make sure that you don't look at the original problem. You have to look at the factored version. So why did this go left instead of right? Because when I factor the negative out of here, that negative made the original problem change to a positive, but then the h is always opposite of what you have. It would be a lot easier if they just wrote it in parentheses, but unfortunately they do not. So be very weary of those negative parentheses and having to rewrite the problem. And again, it helps to just scratch it right out. Otherwise, you look at the wrong thing and you make just a careless mistake. All right, I hope this was a helpful video for you for translations as well as reflections and all the different aspects of transformational graphing.